All right, thank you, Dion.
Okay, welcome everyone to the Trends, Databases, and Standards live QA panel at the 2021 CubeSat Developers Workshop. We are excited to have our panelists and attendees join us for an engaging discussion about their presentations. Before we begin, we would like to thank our sponsor of this panel, MaxIQ. Let's take a quick look at MaxIQ.
MaxIQ represents the X-in-a-Box ecosystem in the United States. X-in-a-Box is a modular technology allowing students to learn and build sophisticated circuitry, such as satellites. The technology requires no tools, and there is no need for a laboratory, including solder station, multimeter, oscilloscope, and other tools. The technology also limits hardware knowledge normally needed to build such a circuitry. X-in-a-Box as a satellite building technology was first demonstrated in 2019, when 40-plus satellites were launched with X-in-a-Box modules from the Antares rocket into low orbit of 200 kilometers, a mission repeated early 2021. An X-in-a-Box solution also spent a month on the International Space Station in 2020, a mission being repeated in June 2021. X-in-a-Box is being used mainly by universities such as Princeton, Stanford, and Georgia Tech, not only to build satellites, but all kinds of Internet of Things projects, teaching students to build and code in the real world.
Okay, thank you again to MaxIQ for sponsoring this panel. MaxIQ is also hosting a workshop on Wednesday, Thursday, and Saturday. Registration is closed currently for Wednesday and Thursday, but there's still time to register for Saturday. And more information about MaxIQ and their workshop will be available in the chat. So now I'd like to introduce our moderator for the Trends, Databases, and Standards live Q&A panel, Therese Jorgensen. Dr. Moretto Jorgensen recently joined NASA's Small Spacecraft Virtual Institute, where she serves in the role as chief scientist. Her experience with CubeSats include having founded the National Science Foundation CubeSat program, which she also managed for 10 years.
Thank you very much, David. And I will go straight ahead and present to you the panel. We have an excellent group of experts, and I hope you have all had a chance to see their presentations. Then you will know that this session spans a very broad range of subjects, but all very exciting. So I'm sure we'll have a really nice conversation over the next hour or a little less. So I will go in the order that the presentations will list. And I will start with the Kishen Raghunath. And I'm really sorry if I massacre people's names, but Kishen is the CEO and co-founder of Plutonics Technologies, a space startup working to democratize space access through reusable satellites. Kishen has over 8 years of experience in the aerospace and defense sector, mostly leading subsystems design on the Orion spacecraft, notably. And what I would like you to do, Kishen, is give you an opportunity for just a few minutes to summarize I know it's an impossible task, your nice presentation, just to remind people what were your main findings and of your presentation. And then I'll ask you a few follow-up questions, and we will go through that for the rest of the panelists. And in the meantime, I hope that you, the rest of the audience, will formulate your questions and put them in the Q&A, which I think should already be open. And then we will add questions from there as we go on. But Kishen, first, please, could you give us a brief summary of your presentation?
Yeah, sure. Thanks, Therese, and appreciate everybody having me here. Thanks to CDW. So just a brief overview, our talk was focused on different ways CubeSats are built and the value chain from mission requirements all the way to manufacturing and launch and operations. We focused on two approaches of getting CubeSats into orbit through the DIY and turnkey solution approach. As options, as well as looking at the new technologies that are really coming onto the market over the next 10 years. And one of those technologies is the docking technology, rendezvous proximity operations and docking technology that we really think is needed to build out the infrastructure required for the booming space economy. And as Therese mentioned, we are an early stage company working to develop a reusable satellite to support the booming space economy. So happy to answer any questions.
Very good. So I will take the moderator prerogative and ask you the first one. So your approach to say one of the advantages is you're really trying to combine the best of being a free flyer, small satellite, and a hosted payload to do your mission as an option. In which ways do you see your system being more flexible and offering, being able to offer lower cost and faster schedule than other existing hosted payload systems? Because as I see it, unless you really buy the whole payload integrator palette of your system, it seems otherwise you have the system that is very much the same as other hosted payload systems would be.
Sure, yeah, happy to answer that. So, we see our system as being like modularity brings about definitely a lot of efficiencies into systems, and the same is true for space. Infrastructure also does the same, and so our reusable satellite bus really will host a lot of the common systems that are currently used on satellite systems, such as propulsion, GNC, TT&C, and communications, etc. Our palette or integration palette is actually going to be a very simple piece of hardware that will be able to just integrate different payloads. And so we're hoping to build that at a very low cost and put most of the cost in the infrastructure piece, which is the reusable satellite bus. And by having that reusable satellite bus in space and ready for customers to use, we're hoping to amortize that cost over a longer period of time, as well as different customers. And that by doing that, we're able to lower the cost of access to space. And by having something that's already ready in space, you're not waiting for a satellite to be built as you're building your payload to get your sensor technology into orbit.
Very good. Good summary. And so your other concept is this that may allow some flexibility is this pay as you go. You only pay for the data you take down, basically, which sounds like a huge, almost too good to be true kind of for the customer. So have you thought about how would these kind of contracts look if, say, you're doing an experimental payload that may never produce any usable data? So do you envision anyway you'll have to sort of buy a minimum upfront, or how do you see that risk being shared also?
Yeah, so I think you're going to have to communicate with your payload otherwise at some point. Otherwise, there's not a lot of usefulness with the payload. But I mean, we want to lower the cost of getting payloads into space and into orbit. That's why we want to employ this pay-as-you-go model. We're definitely trying to be that hardware platform, just as like Amazon Web Services is for software, right? And so by having that model in place, we think we can help more people access space in a faster way.
Very nice. Thank you so much. And I'm sure that has spurred lots of questions from the audience to learn more about your system. We will move on to the second panelist on my list, in the order of my list, which is Professor Mengu from the Kyushu Institute of Technology in Japan. So I guess you're up really late or really, really early to join us here today. Thank you very much for that. Professor developed and launched 16 CubeSats into orbit since 2017. He has been engaged in various international standard activities related to CubeSat and small satellites, including the testing standard ISO 19683 published in 2017. He is now engaged in standardization of CubeSat interface, which is also pretty much the title of his talk. So could you give us just a brief summary of what your presentation was putting forward?
Yes, thank you very much for introductions, and good morning. It is now 5 a.m. In Japan. Yes. So yes, I'm working on a standard of a CubeSat interface, and many of you, if you try to build a CubeSat, you realize that when you integrate, especially, you have lots of issues in interface. And people buy many of CubeSat components or even the platform right now. But having to define a clear interface and also getting clear information about what is the interface and what is the data and those things, it really accelerates the time to make a CubeSat. So that's the reason for in a standard draft, what involved the interface between unit and unit, and the interface between mission payload and platforms. And that physical interface, also documentations to describe those interface. So we are working on, and so that's the international effort. So I hope anybody who are interested join the project. Yes.
Thank you very much, Mengu. So you have already, as I mentioned in your introduction, you have already taken one standard through the whole process of being accepted as an international standard for the qualification and test of small spacecraft and units. So can you talk about what the impact of that has been? Have you seen that that standard is now widely used and adopted by the community? And is it being promoted, say, by agencies? Or in what other way do you measure whether a standard is successful?
Well, that testing standard, we made it because the applying testing method for the big satellites to the CubeSat or small satellite is nonsense. It takes too much time and too much cost. So we tailored and listed just a minimum requirement for the testings. And if you fail that testings, you can never go to the space, something like that. And at least we are also running a testing center at my place, and we are doing a offering testing service to more than 2/3 of the Japanese satellites, also to many foreign customers, especially from Asian regions. And we start from that standard to define the testing conditions. Yes.
So what are some things you plan to do to make sure that your new interface standard will be widely adopted by the community? And also, what do you need for the community to do to help you with that?
Well, at least, first of all, we are now working as a part of the International Academy of Astronautics, IAA, to get the input from academia mostly. And so I'm making presentation all kinds of the small satellite related conferences. And we have a website to call the participations. We have more than 200 the members in that areas.
Okay.
And also, yes. Also, I need support from, especially from industry people. Yes, those who are making component, also making the platforms. And I have the contribution from major the component providers, and now we are starting to approach to the platform providers. And hopefully after this COVID situation is over, I can go and connect those people. Yes.
So we encourage everybody to look up. I think in your presentation, you do provide link to
Yes.
where people can go and find you. Yeah, very good. We will go to the next panelist, and that is Erik Kulu, who has been the curator of the large Nanosats database since 2013. I gather that's his hobby because he says that professionally. He works as a senior space systems engineer at Kepler Communications in Toronto, Canada. And Erik, could you please give us a brief review of your presentation?
Thank you. Yes, Nanosats is a hobby, but it still takes a lot of time. So maybe a brief overview. 2021 is a good year for Nanosats and CubeSats. If you have seen my talk, then we had a previous peak of over 300 launches in 2017, and then a small decline every year since then. But this year we'll probably have a new record, largely thanks to many constellations sending up their first batches, and also thanks to SpaceX rideshare missions and others. Maybe one interesting fact is that the total number of CubeSats in units is almost 4,000 units. So assuming every unit is 1.5 kilograms, then all the CubeSats in total are only 6,000 kilograms, which isn't that much, right? You could almost launch it on a single Falcon 9, but you obviously have to include deployers. Then if it took, for the first 1,000 CubeSats, it took about 16 years, but we'll very likely hit the second 1,000 next year, so 4 times faster. One more fact, that diversity is definitely increasing. We are seeing many more small form factors, pocket cubes, 1/4 unit CubeSats, but also at the same time, we are seeing 6U and 12U CubeSats for many constellations. Which is probably the right way to go. Many educational missions are probably very well off with smaller satellites. It's cheaper, while constellations need more performance and they're going with larger satellites. And then lastly, interplanetary exciting missions are only in the beginning. We only have 2 Mars CubeSats and only 2 GTO CubeSats. And if I may to advertise, next week at the Interplanetary Small Satellite Conference, I will have a talk about exactly on the topic of CubeSats beyond LEO orbit. And maybe that's it. I see there is a good question in the chat, which I might take on.
Oh, okay, you want to do that now, and I can save my question? No, we'll go to the chat for everybody afterwards if you prefer. So my question was, I know you say in your presentation that collecting the information is still your main challenge and what you spend a lot of time doing, that the proactive sharing of information and offers to reach out to you and help give you the information you need is really rare. So shame on all of us. But what are some things you're doing to reach out to the community or to ask for that input? Or are there some other ideas you would like to try to better engage with all the mission owners?
Yes, I guess the thing I could do is to be more active in reaching out to people. I did try like crowdsourcing a few years ago, but unfortunately, when everyone was able to edit the database on their own, it was still rare. And then most of them actually wrote profanities instead of some useful information to my database. So that was a very unfortunate, a trend. And that's why I removed like the public edit option. Yes, it's challenging. I wish that teams would just be more open about their progress on their social media and websites. Even in 2021, I'm struggling to find photos for some CubeSats, and having a good understanding of how well the mission is doing is even more rare. So please post and do more publications and share what's up.
Yeah. And also, I'm curious, what are some of your thoughts for how to make this as sort of a real archive, a sustainable archive for the long term? Because, for instance, you say you rely on linkable sources, but they may not exist for long term. Have you thought about that?
Yes. So something that no one has seen yet is that I am actually collecting like publications into my database, attached publications. So a lot of them are there, and I intend to make them public at some point. But there is still a lot of work to do to get to gather most of them. But after that, it would be like a full storage. Any thesis works, publications, all photos would be there.
Well, very good. I'm sure we will have some nice engagement for you, hopefully, with the audience here. We will continue with the next speaker on my list, and that is not the presenter, but somebody else is here to present the MetaSat presentation and take questions, and that is Daniel Chivis, who is a research fellow at the Harvard-Smithsonian Center for Astrophysics. He is currently leading the MetaSat project, which is an open metadata toolkit for small satellite missions. And will you give us a brief summary of what the presentation was about?
Sure. Thank you so much. MetaSat is, like I said, a open metadata toolkit that can be used to describe all aspects of space missions, including video. There we go. Yeah, including the four main segments, so space, ground, launch, and user segments of missions. A metadata vocabulary is the primary component of the toolkit, and that is pretty much in addition to having lists of terms, each term has a URI, so a unique identifier that is machine readable. And this is very useful for linking data and using MetaSat terms to organize databases and to be used for API calls, connecting different systems, different teams, and stuff like that. And we also encourage people to use our metadata concepts in their metadata schemas. And so with that, we've made our terms optimized for the JSON LD RDF syntax. And we're also working on getting that. We're also working on getting MetaSat terms also serialized in different formats too, including just plain RDF, RDF XML, N triples, and Turtle. So that's like the next step.
Thank you. So I learned a lot listening to this talk, as I'm not sort of an IT person really, or building databases myself. And that's my question to you. How do people get started taking advantage of this and using this? Is it something that can benefit even sort of individual institutions or missions in your mind? Or is it mainly something for people who build databases and such things?
So it's for both of those parties, absolutely. So for let's say like the graduate student working on a small spacecraft out of a university, they could use MetaSat terms and concepts to organize their knowledge management systems. So to keep track of where they are within the mission pipeline, and organizing things, including the data associated with missions, the hardware, the software, and also the personnel of missions, bibliographic data, and stuff like that. But it also is optimized depending on your use case for larger databases. And so one group that we're working with right now the pilot MetaSat terms is the Libre Space Foundation, who operate the ground station network SatNOGs. So that's an example of like a larger group. But we're also working on trying to get more small teams involved as much as possible to use our system.
And what are some things concretely you would like the community to do for you?
Sure.
How can they help you?
Well, I think so. One of the nice things about MetaSat is that it's completely open, and that means that everything that we do is from community feedback. And so with any sort of open standard, which our vocabulary is, there's usually a lot of contention and debate over terminology, over synonyms and stuff like that. So we're trying to be as transparent as possible with how that type of discord occurs. So we use a GitLab repository, which you could find through our website, which is schema.space, to hold those discussions, and we submit and publish issues and with every change that we make, in addition to having a pretty concrete versioning cycle.
So it's just for people to join in and be part of the team. Very good. And finally, last but not least, our last panelist is Robbie Robertson. And Robbie is the CEO and co-founder of Sedaro Technologies, a provider of cloud-based satellite engineering tools. Robbie was previously the product development manager at Ibeos, a space avionics provider, and has held research positions developing physics-based models of spacecraft dynamics at Los Alamos National Laboratory, at the Air Force Research Laboratory, and at the German Center for Quantum Engineering and Space-Time Research. That's very impressive. So, Robbie, will you give us a brief review of your presentation, please?
Sure. Thank you for the introduction. The topic of my presentation was the Small Satellite Reliability Initiative Knowledge Base, or the SSRI knowledge base. It's a very kind of, well, the way that we've been marketing it recently is Wikipedia for SmallSats. This is a tool funded by NASA. It's a NASA website. It lives actually on the S3VI website. And it's a, as the name suggests, meant to be kind of the starting point for people developing SmallSat missions, for them to find information and to link them to other resources throughout the community, like the other tools we're talking about here, and papers, books, websites, repositories, databases that they can use to design their space missions and inform their processes. It's crowdsourced. That's what we're hoping for out of it, to kind of leverage our user base to continue growing this community resource. And so it's completely publicly available, no sign up, no login, and people can recommend content. It was interesting to hear Erik talk about the issues with trying out crowdsourcing. We're hopeful, but we've also placed kind of as I discussed in the presentation, a moderation step where the group, the initiative, can moderate the input from these public interfaces. So yeah, we're kind of marketing it to the community through this presentation, and hope that people will head to the website and start using it, and hopefully contributing as well.
Thank you, Robbie. So this system is designed very broadly to collect and share information across a really enormously wide range of users from all corners, basically, of the small spacecraft community. So what do you see as some characteristics in the way you designed it that you can point to as being especially important to ensure that the information you provide is useful to these diverse users from very unlike institutions with different cultures, working on missions with very different purposes and risk postures and processes or lack of processes? So what thinking went into making one useful tool for all?
That's a great question. I think, having been involved for a number of years, we experienced a lot of kind of, paralysis by analysis, or trying to think of how to answer all the questions. And the group itself is very diverse. We have, the SSRI has, participation from more the new space community, the traditional space community, NASA, DoD. So There's a lot of different voices and completely different approaches to things. And even over that period of time, the technology's changed and the way people design SmallSats has changed. So what we decided to do was just come out with a minimum viable product, something that was not being prescriptive and not trying to address a particular element of the community, but kind of bring everyone in. And which, as you indicated, is very challenging. How do you still stay helpful to those people when your audience isn't so clearly defined? And our solution is essentially to, vet the information that we're posting, the resources we're linking to, and the best practices that we post to make sure it's useful to somebody within the community. But it will be up to the user in the end to kind of decide what makes the most sense for them. Along with the resources, we provide some context and description, which whenever appropriate tries to provide that context and indicate maybe whether it's more appropriate guidance or a more appropriate example for a particular subset of the community. And we made it a live resource that can change over time to try and so that we have the ability to make corrections, and it's not so much pressure to make it perfect and invest heavily up front, but just kind of create something that can grow and evolve with the community.
I think that's perfect. And almost the same question to you as to many of the others. How would you most like to see the community engage with you on moving this forward? What do you need from the community to do?
Well, we need that community participation. We have interfaces on the site for rating resources, for example, and hope to add more user interfaces in the future. So if people log on, even if they're a subject matter expert, we'd appreciate even people that don't need a particular topic page, the content on that topic page, to check it out and rate highly the resources that they found very useful in their experience. And at the bottom of each topic page, there's an interface for users to recommend new content, recommend another software tool, book, white paper, website to add to that topic. And we really, we kind of need that to keep it growing and kind of feed the further growth of the tool.
Very good. Thank you. I think that I will stop there with my initial round of questions. We've already been touching on a lot of interesting topics. So you have also been very busy answering questions while I was doing the talking. Thank you so much for that. So we right now only have one open question left. And that seems to be a generic one, but maybe it was the one you, Erik, alluded to that you would take a stab at answering, is how to monitor the operational status of the CubeSats. We can know if they have been deployed quite easily, yet we still need a way to assess their reliability. So was that the one you wanted to say something to?
Yes, I'll happily share some of my thoughts. It's not an easy question to answer, but so first, operational can be a very wide term. So from one hand, it can be, let's say, a satellite that only beacons, or a satellite that has full free axis attitude control and like maybe propulsion, doing complicated maneuvers. So what actually is operational? And often there is lots of software. Let's say satellite might be operational, but maybe the software isn't fully built up to take advantage of all the hardware that's there. Is it then operational or not? So yeah, it's a difficult issue. From another point, let's say a team does a very simple CubeSat that maybe only sends a beacon, and then another team does a challenging CubeSat with different payloads, very complex mission, and let's say the first team, everything's working, everything's great, but the second team, let's say maybe one subsystem doesn't work. I would still consider that team and second team successful and very positive, because ultimately they did more and they achieved more. So this kind of status about how well the mission is doing is I think pretty challenging, and we would need like full transparency to know it. Third point, it's not that nice to admit that maybe you failed, right? It's not the best feeling to tell to the world that, hey, my satellite isn't working. And with like commercial companies, it's even more challenging, like, because it might influence their customers, investors. So yeah, it's a very delicate topic, and I don't have a good answer.
Yeah.
Thanks.
But I think it's a little bit, it's the same that with the knowledge-based tool, we're all trying to improve the reliability. And for that, we do need to share information on what works and what doesn't. So it's true. So we have another question, unless any of you on the panel wants to follow up on this more, let's just wait. Otherwise, I'll go to the next question. And that's for Robbie, specifically, at least to start. How does your tool rank resources that don't have user feedback?
So currently, when on a resource listing on a topic page, or if you search the resource library directly instead of going to a topic page for the associated resource listing, the resources are listed by rating, with the top rated resources at the top of the list, and the unrated resources at the bottom. So that it does, I assume they're alluding to this, but it does bring up a question of, do the 1-star rated resources deserve to be above the unrated resources? It's kind of a difficult question to answer, because at least someone has interacted with and tried out or had experience with the 1-star resource. So we still kind of put it on top, but that hopefully won't be a question that we have to answer or necessarily find a complicated solution to, because hopefully people will use the site and rate the resources they have experience with. To fix that, we might need the group, the initiative, to go through, reach out to people in their organizations and seed the ratings with some initial ratings from experienced developers.
Mm-hmm. Thank you. I almost feel like I should ask the same question to Daniel. You have, for instance, these definitions, descriptions, is that what you call them, of the concepts. Do you do a rating system on those? Are they all equally good and equally easy to translate to other, do these crosswalks, as you call them?
Yes. So there's two components of that. The first is that we list synonyms for each of our concepts, and those we're constantly adding those. I also envision us adding antonyms eventually, and we also include descriptions for each of our, we call them concepts, but terms works too. But we also have a crosswalk, which I believe Daina had talked about, and that is a one-to-one matching with our term with other standards, other vocabularies, dictionaries, the SSRI, and stuff like that, but also to existing systems. So actually, I've crosswalked, for example, to the Nanosat database already. I've done the same with Gunter's Space Page, GCAT, a bunch of other existing systems. So we're constantly working on trying to pair our terms with others in order to like maximize our own system's flexibility.
So rather than landing on a perfect definition, you just embrace a wide variety and say, this is all the same.
Exactly.
So is there any other comments on this topic? Otherwise, I'll go to the next question. And that is addressed at Mengu Joe. Do you have any suggestion for criteria when selecting a particular flight software? And of course, if the rest of you want to
actually, the answer is no, because the flight software is highly dependent on the hardware, and so also things connected to that particularly CNDH, which communications, which attitude controls the connected. So so there may be a recommendation about how to write the software and how to verify software, but not about how this particular commercial software for those things. So I think it's very difficult to also to sell some individual software. Perhaps it may be a commercial product sold as the development environment or some coding environment, but not as a particular software.
Anybody else have some suggestions to add, some help, advice? Is that something people would be able to look up suggestions for using the knowledge base tool, for instance?
Yeah, we have not. There are 16 pages that are currently completed out of the, I believe it's 64, 62 topic pages that we currently have in the knowledge base. I believe in the next batch, we'll have a page on software, on flight software development, and there's a separate page on firmware development and I think embedded software development as well. And so that will be a place where we can go and share all the various options. And it's a good, I guess, a placeholder solution in the place of a definite answer or a clear single thing to choose, because it's such a nuanced decision where people can just see the options and evaluate it for themselves.
Yeah, I think. May I?
Of course, please.
Yes, I think the software is directly related to reliability. Many satellites fail because of the software things, not for the hardware. And however, it's also very difficult to define very clear best practice of making softwares, because especially in the universities, we assign the task to a student, and student write in whatever way they like. And so it's very difficult to define clear way of the best way of the writing software, best way of verifying. However, it is really necessary to improve the overall reliability. So I really hope that some kind of those best practice or recommendation or guidebook about writing CubeSat flight software.
Very good. Thank you. I think we have a few questions for Erik, follow-on questions. You mentioned how many teams don't have information readily available. For university teams, keeping up with the social media posts is tough when you're managing all the technical challenges of assembling and operating a CubeSat. And I think that's true not just for the university teams, but in general, these missions are often low cost and best effort kind of things. Do you have any ideas or suggestions to encourage or make it easier for academic teams or others to share their information?
That's a great question, Ryan. It's something I'll think more about. But first thoughts are, I love interdisciplinary CubeSat teams. Please do engage other faculties in your universities. Maybe you have marketing departments or journalism or any other fields. And from those faculties, you might be able to find people who are actually very passionate about social media, and they would be ideal persons to do that. Second observation is that most CubeSats are actually fine. 80% of CubeSats publish pretty well, but then those 20%, they might be the ones that failed. And so people easily let the world know about good news, but lack of news is often a sign of actually a bad news. And then large amount is also maybe CubeSats from China, where the language barrier and culture barrier is larger, and that information just doesn't reach me through LinkedIn and other channels. So yeah, maybe have to think about it.
Yeah, there was a suggestion from one of the audience, whether you have considered having a small team to dig more information about the satellite teams, get in contact with them, etc. But I assume that's a resource question.
Yes,
who are your team? Is that it?
No, I would love to. I'm open to more collaboration opportunities. It's more common that people ask me for the database, but if it's more win-win, then I'm also more willing to share the raw data. And yes, secondly, as I mentioned, most are fine, but yes, like I have a long list of contacts that I have asked some status updates and they have never responded. So you will always have some percentage of people who never respond. And yeah. And third point, we also have military CubeSats, and then that also complicates. And yeah, when you put all of them together, you get that 10 or 20% of CubeSats that you don't have much information about.
Yeah, there's another question, but I'm not quite sure. It says it's for you, Robbie, but I'm not quite sure. It talks about software. How is the software behaving in case not all the inputs can be fed to the software? As an example, the orbit of a CubeSat is not always fixed at the very beginning of the mission. And how is the software behaving in this case? But I'm not sure you can answer because I'm not, to my knowledge, this is not the kind of way your software works.
No, I don't, and I don't have experience. Maybe Mengu would have a better response here, but my assumption is that you have some, case in your software, in your flight software for this initial period of the mission where you don't necessarily have an orbit solution. But, maybe Mengu has some perspective on this.
Well, I'm not quite sure about these questions.
No, that's okay. We will encourage the person asking the question to get in touch with somebody in not real life, because they're not allowed to, but online to find either any of us or somebody else during one of the Zoom meetings at the rest of the conference and see if they can find an answer to that. Thank you very much. So I think I will move on to just some closing statements, and thank you so much. You've been a wonderful panel, and it has been a lot of very interesting information. I certainly have learned a lot. So to end, I think I would like each of you to give you the opportunity again, going around to just say some final words, but also maybe from your perspective, what is something you are excited about for your own project or for CubeSats in general for the coming year? And Kishen, you will go first again, please.
Sure. Yeah, no, thank you for the opportunity to talk here today. Yeah, I think as we've done our research, just the booming space economy, we've seen amazing space exits over the last year coming into the open market. And so we're really seeing space commercialization take place. And with that, I think new technologies will enable architectures to allow us to actually move to the moon and beyond. So we're really excited about that and really excited to see the growth of the space economy. Thanks.
Thank you. And Mengu? Some final words from you.
So to make a standard, input from the community is very important. And also making a standard is not to bind anybody, is to help and promote. Yes. So please join, and we'll have the workshop in December in Japan, hopefully. So please visit our website. I think I put that in Q&A sessions, and so you can join this effort. Thank you.
Thank you. And Erik, what are you excited about?
I'm excited about more commercial constellations scaling up. I think that's really important for the sustainability of the industry and many startups. And secondly, yeah, as Kishen mentioned, all the interplanetary CubeSats that are still coming, launching on SLS and more after that.
Thank you. And Daniel, what do you see in your future?
Thanks again for letting me fill in for Daina today. I'm also excited about interplanetary missions coming forward and seeing how MetaSat could be used to describe that. But I'm also excited to see how MetaSat can act as the glue between all of these projects and everyone in the room as a way of linking everyone together in a way that's open and collaborative. And so, like I mentioned before, I hope to hear from some of you through GitLab and through our website, schema.space, and hopefully we could keep building this together.
Thank you. And Robbie, you get to have the final words. What are you excited about? You need to unmute, otherwise
Thank you. So I was just saying thank you. And as I said at the beginning, we're just excited to finally have this tool we've been working on live and have it available to the community. So this year we're excited to see people start to use it, learn from that, and continue to improve it. And as part of that, look into opportunities to connect with these other tools that are out there, whether it's the simplest case by just sending our users to these places for this valuable information like standards and databases and what MetaSat is providing, and then maybe also collaborate more closely to improve the whole kind of ecosystem of tools to support SmallSat developers.
Thank you. And then I will just read the last comment we just got from one of our from one of the attendees. Was a big thank you to the panelists for the info you provide to the community, and I couldn't agree more. So thank you both for your presence today, but also what all of you do to provide really good new systems, tools, information to the community. So thank you very much.
Therese, before we go, I meant to mention something. I was told to mention something. I forgot.
Please.
We're having a side meeting to gather input from the community on the tool, and that's on from 8 to 9:30 a.m. Pacific time on Thursday. So it's called Sedaro Technologies SSRI Knowledge-Based Demonstration. So we really want people to join that, participate, and help us shape this community resource.
Excellent. Look for that Thursday morning and maybe see many of you there again. Anything else anybody wants to do or say? Then I thank you all. It has been really great. And I think the next thing on the agenda, we have a short break. And yeah, back to you, David. You can close it out, I guess. Thank you.
Thank you, Therese. So that concludes the Trends, Databases, and Standards live Q&A panel. Thank you everyone for joining in the discussion and providing great questions. And a special thank you to the moderator, Therese, and then all the panelists for leading such an exciting panel. It was really interesting and very informative.
So thank you. Bye.